Around 4.6 billion years ago, right where we're standing now, there was nothing but a nebula. But what is actually a nebula? A nebula is essentially what's left over after one or more dead stars, which are very gorgeous and consist of gas and dust. All the matter, and even some elements that are present in a human body, were manufactured at these stars sometime in the past and exploded, scattering themselves throughout the cosmos after their demise. This nebula entered the phase of compression. Why? Slowly but surely, the gravitational center attracted more and more material to it, and so much pressure and temperature was achieved that nuclear reactions triggered, and a star was born, which we came to know as the Sun. This young star that was new in formation turned out to be a kind of a bully with a strong gravitational pull, so the gas and dust in the nebula began spinning around it. The same goes for all the rocks and meteoroids in that nebula. They all got caught up. That is, they weren't free, as in when they were part of the nebula, and got trapped by this young and powerful star. This stage is called the protoplanetary disk. It denotes that there is a star, and gas, dust, meteoroids surround it without a planet. But bear this in mind, under these particular circumstances, it is a vicious circle. The planets are going to come into being. There is no question about it. Here, small things are revolving around the Sun in a disk, and in many millions of years they become larger and larger through collisional growth until they reach a size that we define as a planet. The region around the Sun was overly hot, and as a consequence, only rocky and metallic materials were left behind. These are the materials which eventually formed the rocky planets, such as those of the likes of either the Earth, Mars, Venus, or even Mercury. But farther from the Sun, where it was cooler, other gases were also free to remain, and later they could further facilitate the condensation of gas giants, such as those including Jupiter, Saturn, Uranus, and Neptune. Let's discuss Earth now. In the history of the Earth, when it was forming, it was like a melted ball, so hot that even some rocks were frying the hell out. This period, which lasted for hundreds of millions of years, is known as the Hadean Era. Among the elements that made up this rocky sphere, there were hydrogen and oxygen, which are the elements needed to produce water. However, there was no water as these elements existed separately. You should know that the most abundant element on Earth, both then and now, is oxygen, but not in gaseous form. It formed complexes with other elements in the form of oxides, such as iron oxide, titanium oxide, and several other oxides. The oxygen that existed back then couldn't combine with the hydrogen present to form H2O and create water. So here's a question. Where did all the water we see now come from? How could water even exist in such a hellish environment? Most of it came from space. And no, I don't mean rain. I'm talking about meteorites. You should know that in our solar system, there are plenty of meteorites which roam aimlessly, crashing into objects. An asteroid belt consists of millions of meteorites as well, and, in all, there are about 2 million meteorites more than a kilometre across. This belt is situated between Mars and Jupiter. It is good to note that what we are talking about now is the correct depiction of the solar system as it stands today, but at that time, there were millions of times more of it. Among these meteorites and asteroids floating around in the solar system, there was a type of meteorite called chondrite. Now, what's a chondrite? These chondrites are rocks that contain water. Not like a coconut or a container with water inside, no. These rocks had a structure that held water, or H2O, within them. They don't look like they have water, so where's the water, you might ask? You cannot take them out without thawing them. Water is produced during their melting. Also, what was going on with Earth at this moment? It's in its Hadean Era and molten. These meteorites kept hitting the Earth's crust repeatedly and melted, creating a small amount of water which not only helped to reduce the high temperatures on the planet, but was also slowly collected on the crust of the Earth. You might think that the water that gets into the molten material wouldn't stick around, that it would just evaporate. However, it also did the other thing. It brought temperature down, which made sure that all didn't evaporate. Some of it remained. Don't think this happened overnight, or even over a year or two. It didn't even happen in 1,000 years. To create our beautiful Earth, we still needed hundreds of millions of years. Time didn't really mean anything here since no one was living on Earth, waiting for it to be ready, so it just took its time. Sometimes, it can actually be said, time loses its meaning. For us humans, and indeed all living beings, it is irrelevant, the time which came prior to the actual existence, for one cannot fully appreciate how long that period lasted. It's probably better that we can't understand it, otherwise we just create unnecessary worries for ourselves. Another reason the water didn't all evaporate was that the atmospheric pressure was much higher than it is today. During this Hadean Era, atmosphere density was so high owing to the large amounts of carbon dioxide that the atmospheric pressure where we currently reside was 230 times greater than what it is today. Chemists state that within a specific repository, when the pressure is much higher than average, additional energy is needed to boil water. These days, in our atmosphere, water at sea level boils at 100 degrees Celsius, but in these earlier years, with 230 times the pressure, this could rise to over 300 degrees before any bubbles formed, leading to a boiling sea epic instead. Even today, it's possible to test and experience these levels of atmospheric pressure as well. For example, at sea level, the boiling point of water is 100 degrees, but it's a different story when you go up a mountain. For instance, at the summit of Mount Everest, which is around 9,000 meters high, the water won't reach 100 degrees before it boils. It'll boil at around 68 degrees. But that's not the whole story of water. Roughly 4.5 billion years ago, one more event occurred, which threw Earth into chaos again. A planetary body, roughly the size of Mars and referred to as Theia, crashed into Earth. The impact was so massive that a big chunk of these two planets broke off and got thrown into space. And you probably know that this big chunk later formed the Moon. This head-on collision, once again, increased the temperature of the Earth's crust, and all the water that had been collected until that time again came to the vapor state. Following this impact, Earth started gaining water once more. This time, however, comets were also a big support apart from just meteorites. Comets are essentially big chunks of ice, and when they get close to Earth, their ice evaporates and forms a tail that we see as a comet's tail. When they crashed into Earth, they added a lot of water and organic materials to the planet. As we pointed out, this did not occur in 1 or 2 years. For millions of years, these meteorites and comets kept crashing into Earth, evaporating, going into the atmosphere, and eventually their impacts helped cool Earth down bit by bit, so water could stay in liquid form and not turn into gas. The water that evaporated over hundreds of millions of years kept getting denser and denser until it finally burst. Not literally burst, but it started raining. You might not believe it, but this rain continued for millions of years. That's right, millions of years of continuous rains. And you can probably guess that the areas with holes and depressions got filled up, turning into seas and oceans. That's when our rocky and molten planet transformed into the beautiful blue planet we see today, ready for all sorts of life. If you'd like, we can make a video of these millions of years of rain for you. Present day, more than 70% of the surface is covered by water. But then, you should know that water on Earth is not a scarce resource in the universe. It's just that it's trapped. For example, if you look at Jupiter's moon Europa, it's about a quarter the size of Earth, but it has twice as much water as Earth. However, the water is trapped under a thick layer of ice, which they say might be tens of kilometers thick. It's also curious that this water is always being recycled as well. This indicates that the water the dinosaurs drank 65 million years ago is the same water we are drinking these days, with the exception of having been recycled hundreds, even thousands, or probably millions of times already. As always, it makes you realize that nature and the universe always find their way. What do you think?